Earlier, we have gone through details with respect to web or mobile application architecture. We'll have backend servers and then we'll have database. Typically, users will interact either through web or mobile to operate against our application to purchase products. In this lecture, I'll actually walk you through the details about purpose-built databases. Purpose-built database means for a given purpose, we'll use a specific type of database technology and we'll build our application. When it comes to purpose-built databases, there are different categories. Already we have seen RDBMS. The examples for RDBMS are nothing but Oracle, MySQL, Postgres, MS SQL Server, Sybase, etc. Also, we have gone through details with respect to data warehouse technologies. The examples for data warehouse technologies are nothing but AWS Redshift, Azure Synapse, GCP BigQuery, Teradata, Databricks, Snowflake, Greenplum, Vertica. These are also known as MPP platforms. MPP stands for Massively Parallel Processing. All the data warehouse technologies these days are also known as MPP technologies. On top of RDBMS and data warehouse or MPP, we also have NoSQL. The examples for NoSQL are nothing but MongoDB. Then we have Cassandra. Like this, there are hundreds of types of NoSQL databases. MongoDB, Cassandra are a bit popular ones. Then we have search-based database technologies. The examples for search-based database technologies are nothing but Elasticsearch. Also, we have something called as Solr. These are the examples for search-based database technologies. Also, we have graph-based database technologies. The classic example for graph-based technologies is nothing but Neo4j. As of today, we have these different types of database technologies. They are nothing but RDBMS, data warehouse or MPP, NoSQL, search, graph, etc. Depending upon the use case of your application, you use a relevant category. Within these categories, we have choice. For example, if you wanted to build a transactional based system where the customers purchase products from you and you deliver products for them, RDBMS is a popular choice. Within RDBMS, Oracle is a popular choice. In the similar manner, depending upon the use case for the application with respect to your organization, you should be able to choose appropriate database technology within these categories. That being said, when it comes to purpose-built databases, we use databases that are supposed to be used for specific type of use cases. Let's do some case study so that we understand what purpose-built databases actually mean. If it is too much for you, don't worry too much at this juncture. You just think that there will be different types of databases which will act as a source for data engineering applications. As long as you understand that point, you are good to go. Now, let's get into the details related to purpose-built databases. For that, I'll be going to LinkedIn as website. Let me go to linkedin.com. In this case, I have not logged in. Let me log in into my LinkedIn account. Now I am logged in into my LinkedIn account. If you look at this, we are just seeing the activity. For the activity, we don't need to use RDBMS database. We should be able to use some NoSQL database. Now, if I go to me and if I go to premium features, we will see subscriptions and other details. When it comes to premium features, there are transactions involved between me and LinkedIn. For these scenarios, we should be able to use RDBMS category of database technologies. Then if I go back to my LinkedIn feed and then if I go to my profile, I should be able to see the details with respect to my profile. Again, to store the profile details, I should be able to use NoSQL database rather than RDBMS database. If I go to jobs here, depending upon my previous job search, I will see recommendations here. There might be some machine learning algorithms that are running under the hood. It uses different types of database technologies, distributed computing frameworks and all. The processed data with recommendations will be again stored in NoSQL or search-based databases. Depending upon my previous activity, I'll be seeing the relevant recommendations here. So for the backend processing, they might use big data or data engineering technologies with distributed computing. When it comes to representing this data on screen, the processed data might be in NoSQL or search-based databases. From there, the data is served here. That is what purpose-built databases means. For each purpose, we use different types of database technologies. Not only databases, but also the different types of application servers, different types of frameworks, different types of programming languages, so on and so forth. Purpose-built databases is the concept of microservices architecture. These are some of the advantages of microservices architecture: cost-effective, scalability, federated queries, purpose-built databases. We have spoken about purpose-built databases here. The main reason why I am talking about purpose-built databases is because these will act as a source for our data engineering applications. We not only have RDBMS database technologies such as Oracle as a source for our data engineering applications, we also need to deal with other types of database technologies as well. It can be DocumentDB or NoSQL. It can be search-based database. It can be graph-based database. Sometimes we might even use these as targets for our data engineering applications. You will understand once you get into serious data engineering. For now, just keep in mind that these purpose-built databases for large enterprise will act as a source for downstream data processing. Typically, we use data lake or data warehouse for downstream data processing. That being said, make sure you understand the phrase purpose-built databases, and also keep in mind that you might have to work with all these types of databases as data engineer.